Hey guys, welcome to this continuation video. Today I'm going to show you how I process the M16 Eagle Nebula in PixInsight. I'm going to show you how to make this from this. My name is John Robinson, the Astrotard. You're watching the Deep Sky Channel. So most of us, I'm sure, have our own preferred methods to do post-processing. I lean towards PixInsight because that's what I know and it seems to be very capable. I also like to shoot in narrowband because I live in a very light polluted area. I'm in an urban area in North Dallas. My skies are always light polluted or cloudy or some reason that's giving me a challenge. So narrowband is much better. I also like to mix in the Hubble palette. The Hubble palette is different. I think I like the color gradients a little bit better in the Hubble palette versus the natural palette. And so what I'm going to show you today is my method for using PixInsight on narrowband mono images mixed in the Hubble palette. I've opened up PixInsight here. I've launched my shortcuts that I use frequently, and let's go ahead and walk through this. So we're processing the M16 Eagle Nebula. If we look at our raw data here, we can see on the folder for lights, we have how many? 513 files, half of them. I would say 250 image files, the other half are text files. So we're going to convert these, especially the 300-second, the 5-minute ones, and make a beautiful picture. This is our reference. We're shooting for this. I processed this previously, and this is something that I created. And I like to bring this up to remind myself of where we're going. All right, the first thing we're going to do is choose the good from the bad. We start with the Subframe Select tool. We add the files from the lights, and I'm just focused on the 300-second frames in here. So let me just grab all those and put them in here. And I'm going to choose an output directory called the M16 Best Light. So those that we choose to save will go in there. And I'll go ahead and, so right now we're doing a measure subframe, and I press this button to measure those frames. Since I've already run this before, it'll be really quick. Normally this takes a bit of time, maybe 5 minutes for this to finish. But since I've already run it once, it's already created all the files. Okay, so I'm going to look at 3 things here in the Subframe Select tool. I like to look at FWHM, which is full width, half, medium, something like that. Basically is a measure of clarity of your sky conditions. If you had Bortle 1 clear skies, you could probably be down in the 1.0 range. But for me in Dallas, I'm between 2.5 and 4. It's a pretty good range. So what I want to do is anything that's above 4.2, say, I'm going to throw out. So I'm going to sort up here on FWHM ascending, come down to the bottom and find anything that's in this range here, 5s up to about 4.1. Those are all OI images. And I'm just going to go ahead and remove them. So we're not even looking at those guys. The next thing I'm going to look at is stars. Just a simple look at the star count. So I'll look up here for the number of stars, and you can see that the best cases are 2,300 and the worst case was around 800 stars. Let's look at the graph of that as well, stars. So these ones maybe below, let's draw the line at around 1,200 stars. Anything below 1,200 I'm going to throw out. So I'll grab here from 800 down to 1199, and we will remove those guys. So we're not even looking at those guys now. Now all this is doing is making a list. It hasn't actually touched any files. The last thing I want to look at is noise ratio, signal to noise ratio. And I'll do that on the graph as well, noise ratio. So our good images, like our HAs, are going to have a pretty good noise ratio of, you know, in the low numbers. And those that are really bad will have a high noise ratio in the higher numbers. So looking at the graph here, I'm going to throw out anything that is above, let's call it a 88. So we'll start from 88 on down. There's quite a few of those, probably all oxygen, maybe some sulfur. So we'll start right here. Here's the first 88. And that happens to be an HA. Okay, the rest of them are mostly oxygens. So we're going to remove those guys as well. So we're really just looking at good FWHM, good stars, and a good noise ratio. All right. So as I said, this hasn't touched anything. All this did was work on an active list here. What we're going to do next is save that list to the output subframes, and it's going to save it to that folder, Best Light. When I press this button here, it'll go ahead and save them. And since I've already done that, I won't press it. But when you do press that, it will save it to this. All those frames that you've saved in that list will show up. The next thing we're going to do is do a little bit of blink. So blink is a tool that I like to use to just look for passing airplanes and other clouds and things like that that can show up in Cloudra images. So of all those images that we just saved in our Best Light folder, Best Light, let's select all these guys. We'll add them in there. And this will take a while to add. After they get added, then I'm going to press this button right here, which is a histogram transfer stretch. What we're going to do is just kind of look for any bad frames. So we'll start at the top. I'm going to set this to 0.3 seconds. We'll just press play. And I'm looking in here for any anomalies with my finger on the pause button. Any clouds or any weird things that would show up in the image, I'll pause. I'm not too worried about, ooh, there was a cloud. Okay, so that may be a bad one. We'll move this guy over to a folder called bad, which I have under Best Light. And I think there was another one here. There's another one. I'll move that guy over to the bad folder. Looking for airplanes or clouds here. Ooh, there's one. Do you see that? Okay, move that. I could probably still use the image and the airplane streak would get averaged out, but I'll just take it out of consideration. We have a lot of data. There's another small one there. Move that guy over to the bad folder. Keep on trucking here. Okay, now we're back to the top. Okay, so that did a pretty good job. Let's close this out. And now what we're left with is our Best Light folder. And those are all of our images. Looks like we have 139 after all was said and done. We started out with 225. Now we have 139, so we lost maybe 80 or so. And these are the ones that didn't survive the blink test. We're going to go up to Script, Batch Preprocessing, and we'll go ahead and select all these 75 gains first. So anything with a 75G in it, 75, will come first. Those will be the oxygens and the hydrogens. I'll add some flats. The flats I had already captured, and I have not touched the imaging train since doing so, so they should be good. So we're going to do oxygen and hydrogen, 75G. flats. Darks, we're going to do a dark 375G and a bias 75G. I'm going to use a master bias, dark and flat, since I've already created those masters. And I'm going to use this, pick a good reference there. Maybe the first hydrogen in the list. Now, if I were smart, I could let Subframe Selector tool tell me, inform which one to use, but it's okay. I think that's pretty good anyway. Okay, I've completed the calibration, registration, and integration on all those files. Let's look at the result in Best Cal. Here's the calibrated lights here. This is with the darks, bias, and flats applied. I have the 75 and the 139s in here. And then we have the registered. This is where we did a star line on that guy right there. We also created drizzle files along the way, which is part of the script. And then it did the integration in the master folder, H, O, and S. This is our integrated 5-minute subs for the Eagle Nebula. And let's just look at those. We'll get rid of the rejection, high, low, high, low, high, low. We'll do a quick stretch. I'm going to use a script to do that, auto STF, because I'm lazy. Okay, and there they are. And then I'm going to change the name on these guys. This is my S for sulfur. This is oxygen, hydrogen. Let's go ahead and rotate these. Rotate counterclockwise 90. Put that at a 1:9 ratio there. So we can see these side by side. The oxygen, 1:9. Image, geometry, rotate counterclockwise. There's oxygen and sulfur, 1:9. Rotate that guy as well. Okay. Okay, so we're going to go ahead and crop these guys to get rid of that anomaly there. Crop that guy. And I'll just do right from here on down to there. Before I hit apply, I'm going to first apply it to the sulfur and the hydrogen, so they're all aligned. And then finally do it on the oxygen. Okay, that's good. So we're all integrated, cropped. Now we're going to do a quick automatic background extraction. I'll move this guy down here. Do this for each one of these. First sulfur. Throw the background away, throw sulfur away. This becomes my new sulfur. Put him on 1:9, stretch him. Okay, repeat that for these other guys. Just cleans it up a little bit. Maybe I could do it side by side. You can sort of see the difference for the oxygen there. Yeah, it looks a little bit better. Takes care of some of those vignetting. Close that, rename you to oxygen. Put you in the middle. Same thing, ABE over here. Close that, rename him to hydrogen. Just 1H, 1:9, stretch. Okay, so there we're good. Now we're going to do a clone stamp fix. Well, we can clean them up later if we find them later. Okay. All right, so we're good on that. But if we were to do that, let me just show you on this finished image how I would approach that. You do this one on each of the subs. You'd bring this clone stamp tool over here and just sort of copy paste. Pick a reference point here and then dab it. You do that on each of the subs. And once you've done it for this one, you can apply that to each of the subs. Okay, and I don't see any anomalies in here that we need to clean up, so we'll skip that step. That's good. Okay, now we're going to do something unique. Before we get into pixel math and stretching, I like to, for Hubble palettes, I like to linear fit on the blue channel. Blue channel is primarily oxygen. So I'm going to do a linear fit of hydrogen and sulfur based on the oxygen channel. So I'm going to drag the linear fit of oxygen over to sulfur, so it'll apply the luminosity that's inherent in oxygen to sulfur so that the average or mean sum value, I guess, of all the pixels are the same. I think that's how it works. And it might look dim and odd to you at this stage. Don't worry about it. This will all work itself out after we do the mix for the Hubble and the stretching. This will all work out. I'm not worried at all that these images look different, especially that overcast look, that foggy look. Not worried at all. That's what I expect at this point. So for pixel math for the Hubble palette, there's a couple things ways you could do this. You could just do SHO, a traditional Hubble palette, and it would look like this, which is not too bad. Or I like to do a modified version of the Hubble, which is 80% sulfur, 20% hydrogen, 80% oxygen, 20% hydrogen, and then oxygen. So I'm mixing my hydrogen in the red and green, mixing my oxygen in the green and blue, and sulfur kind of gets isolated so that it's only in the red channel. So that's how this is going to work. Let me show you how that looks. Stretch that guy. Okay, I like that. That's a good starting point. We're going to go with that, and we're going to call this my Hubble. We'll just call it that. We're going to do another automatic background extraction from there. Just to clean up the haze a little bit. Close Hubble, close that guy, rename him to Hubble, and stretch him. Okay, that's looking good so far. Don't worry, this will be our reference, right? It's gonna look like this when we're done. That's what we're working towards. Yeah, we're gonna stretch this guy. So we'll do a histogram and we'll stretch this guy. Put that on the histogram. Notice how it moves that curve up there on the RGB. Stretch that guy. Turn off that stretch. Okay, now the stretch is permanent. So Hubble is stretched. The next thing I'm going to do is create a Lume file. Now this is the real magic to creating this whole thing, is the luminosity. Your Lume channel really is going to make the details pop. And the way I do the Lume channel is by combining all of the three that we just created, H, O, and S. There are other ways of doing a Lume. You could shoot Lume, of course, or you could just use hydrogen. But I like to mix all three and create my own Lume channel. Okay, this is our Lume. Okay, now you remember we had to rotate and stretch. So we'll start with our oxygen and say, align yourself to oxygen, Mr. Lume. Close that, close that. We'll do a stretch. Actually, we'll do a permanent stretch on him. Okay. Okay, we'll rename him to our Lume. So our Lume now lines up with our Hubble. Now for the rest of this, we're really going to focus on dialing in that Lume. So let's clean up our desktop here a bit. We won't need these guys for a while. Actually, the HOS we're pretty much done with. We could even close them. All I really need at this point are the Hubble and the Lume. Okay, so we're going to spend some time now cleaning up this Lume before we apply it to our RGB Hubble, SHO Hubble. We're going to clean this Lume up. I'm going to duplicate this guy, grabbing Lume, dropping it out, it makes a duplicate, and then I'm going to apply that duplicate as a mask, so it's masking the background. I'm just focused on the mask on the nebula. We're going to do an unsharp mask on that guy. So the preview, and let's actually get closer in. So let's make a preview for the preview right there. And I want to look at this very carefully before I apply the results. So I'm wanting to make sure I get good details in there. And that's a little bit too much. Pull that back a little bit. I think right around there is good. Before, after. Before, after. It's pretty good. Okay, so let's apply that to the real thing now. Okay. Okay, good. Now we're going to invert that mask. And I'm going to apply this multilinear transform. So I'm doing this for 3 layers. First layer is 100, second layer 90, third layer 80%. I'm applying noise reduction on those 3 layers for multi-scale linear transform. And I do this on the background. So I've inverted the mask, so I'm protecting the nebula and applying the MLT to the background. What this has the effect is, I'll show you, of smoothing out the background. So this is the after. Here's the before. Can you see that? Before, after, before, after. Now we can dial that in a little bit on the stars. Now that that's done, let's go back to the mask here. Show the mask. Let's invert the mask, protect the background. And that Lume is a bit too bright for my liking. So I'm going to dial that down a bit. So let's do a preview on that. And let's dial that down. Just make it not so luminous. Right about there. That's good. Okay, so now I'm going to focus on the pillars of creation in the center there. And let's do another mask on this guy. And we'll zoom in there. And I'm really looking one more time at unsharp mask, and I'm really looking at the pillars to make sure that I got them nice and crisp. Let's just make sure it's not too extreme. Okay, that's pretty good. Let's apply that to the major Lume now. Okay guys, I'm sorry to keep up the anticipation, but this video is getting way too long. I've decided to break it up and do a third video. So let's recap. In this video, we did a quality check with our subframe selection and our blink tool. And then we did our calibration, registration, and integration using the batch preprocessing script. And then we prepared our subs and we stretched them. And then we did a Hubble palette mix. I showed you my secrets for doing the Hubble palette. And then finally, we created the all-important Lume. In the final video, I'm going to show you how I combine the Lume that we created with the Hubble palette to fine-tune those details in the final image. Well, I hope you found this useful. If you did, hit subscribe. Thanks for watching. See you next time. Bye.